This video will discuss strategies for multiplying by nines. On the next screen, I'm going to flash you some dots. Watch carefully and tell me how many dots do you see? Think about that. I'm going to show it to you again. How many did you see? Hopefully you saw 40 dots. So this is in a 10 frame, which we've been using since kindergarten, and we know there are 10 sections in a 10 frame. Since there are 10 sections and there's 4 dots in each section, 10 groups of 4 is 40. So let's use this to figure out the next one. Again, I'm going to flash some dots at you. Tell me, how many do you see? Think about that. How many did you see? Hopefully you saw 36. So I can use what I know. If all of these would have been filled in, I know it would have been 40, but there's one section missing. So really, I could think of this as 40 minus 4. 40 minus 4 is 36. So using this is the strategy, this is the thinking that we're going to be using to solve our nines. So here's another example. 9 times 7. So if I have 9 groups of 7, all along we've been leaning on our 5s. I could think of this as 5 groups of 7 and 4 groups of 7. Those are kind of some not nice numbers to add together, but if we rely on our 10s, that makes it much easier on ourselves. So I'm going to think of this as 10 groups of 7. Well, I know all of this would be 70, but I have to subtract one of those extra groups because it's 9 groups of 7. So 70 minus 7 is 63. So symbolically, here's what that looks like. Really, I thought of the 9 as 10 groups minus 1 group, and the reason I did that is because my tens facts are easier. So 10 times 7 is 70. I subtract that extra group of 7, and I can get to 63. Now, one of the hard parts of this strategy is sometimes it gets confusing. Do you subtract the 9 or the 7? But if you always visualize this 10 frame and what that looks like, you can easily see which one of the factors you're actually subtracting. We added an extra group of 7, so that's the one we have to subtract to find the true answer to 9 times 7. Here's another model, another way to think about this strategy. So I have 9 times 6. Again, I could think of this as 5 groups of 6 and 4 groups of 6. Those aren't nice numbers for me to think about though, so instead I'm going to use my 10s. I'm going to actually add a group on and think of this as 10 times 6, which is 60. And then I know I just have to subtract that extra group. So 60 minus 6 is 54. So symbolically, here's what that would look like. I thought of the 9 as 10 minus 1, and really I'm using the distributive property. So now I'm distributing that 6. I know that 10 groups of 6 is 60. I'm subtracting that red row. I'm subtracting that one group of 6. 60 minus 6 is 54. So here's our final model to think about this problem. I know that 9 times 8, if I think of it as 10 groups of 8, that's 80. And then I'm just subtracting that one extra group of 8 that I added. So 80 minus 8 is 72. 9 times 8 is 72. So you might have heard of some tricks. There are some tricks out there to solve your nines. And the problem with those tricks is they end at 9. They no longer work after we get to 9. So using your 10s is a strategy that can work for any number if you multiply it by 9. So let me show you. 9 times 15. So again, if I use my 10s and I think of this as 10 times 15, that gets me to 150. But I know that thinking about that 10 frame, I've actually added an extra group of 15, which I want to subtract now. So 150 minus 15 gives me the answer of 135. So 9 times 15 is 135. When you use the 10 strategy to help you with your nines, you can solve any number, any multiplication problem when you multiply it by 9. So remember, when multiplying by nines, think of a group of 10 and then subtract that extra group.